So let us now solve this problem on cone. A cone of diameter of base 50 mm and height of axis 80 mm is kept on HP on one of its points on circumference such that axis makes 30° to HP. Draw its projections. So let us understand with the help of this model. This is a right circular cone of diameter of base 50 mm and height of axis 80 mm. It is resting on HP on one of its points of circumference. That means in initial position we have to assume that the whole base is lying on HP. So this is the initial resting position of the cone. In this position we have to first draw its top view and front view. Now why top view? Because in top view the true shape of its base circle is seen. That's why we have to first of all draw top view, which will be a circle, and from that we have to project front view, which will be a triangle. Now after this we have to incline this cone such that the axis now makes 30° with horizontal plane. So if I tilt it something like this, it is now resting on one corner, one point of its circumference, and at the same time axis is also making 30° with horizontal plane. So we observe here that the initial front view, which is a triangle, is now getting tilted at certain angle. So we have to reproduce front view such that the axis now makes 30° with horizontal plane. So after reproducing front view, from that we can draw its top view. Let us see how to draw projections of this solid. So we see here top view is a circle of given diameter 50 mm, and as we have to now consider few generators on the lateral surface of the cone. So these are all generators considered on the lateral surface of the cone. So for the purpose of drawing we now take only 8 generators into consideration. So this whole circle is divided into 8 equal parts. So let us name the points on the circumference, and the apex O and axis is OP. So this is the top view of the cone. Now from this we have to project its front view. So draw projectors through all the points. First of all, mark axis in front view, and along the axis mark height equal to 80 mm. So draw remaining all generators by projecting all the points of base on XY line. Then join all these points with the apex. Generators are always thin lines. Name these points in front view. This is height, which is equal to 80 mm, and diameter of base circle as 50 mm. So in the elevation we have to name the points. So with this we have completed the front view by naming all the points of base, apex and axis. Now this cone is to be tilted such that axis now makes 30° with horizontal plane. So we have to reproduce this front view such that the point A lies on XY and at the same time axis makes 30°. So for this purpose, first of all mark A dash on XY through A dash. Now as axis makes 30°, its base is going to make 60°. So through A dash draw line at 60°. So this is the line which is at 60°. Now along this line, first of all mark midpoint of the line as point C dash and G dash. So these are points C dash and G dash. And now we have to reproduce this. So with respect to C dash, by using compass you can measure distance of B and D. So take distance of B, which is the distance of D also, and mark these 2 points. So these are points respectively B dash, H dash, and these are the points D dash, F dash. This is extreme point V dash, point 1, and now this is also point P dash. So through this, draw a line perpendicular to base. To this base we have drawn one line perpendicular, which is the axis. So along this line mark height of axis, and now join apex with all the base points. Remember, here only this outline of the triangle should be thick, remaining all are generators, and that's why they should always be drawn by thin lines. So O dash and P dash is the axis. So we have reproduced this front view such that axis makes 30 degree with XY or with horizontal plane. Now from this we have to now draw top view. So for this purpose we have to draw projections through all these points and projections from all the points from top view. So draw vertical projectors from front view. First we have to draw all the projectors from front view. Now through the points in top view we have to draw horizontal projectors. The projectors from all the points from front view and projectors from top view. Now we have to locate the points. Like if you want to locate point A in top view, it is at the intersection of A dash from front view and A from top view. So this is point A. Likewise, projector from B dash and projector from B, here you get point B. So this way if you go on tracing, and now here you get apex, intersection of O dash and O is point O, and intersection of P dash and P is point P. Now we have to join all these points. So as we did in the previous case, the outline of the solid can never be dotted. So first of all join all the points on the outline by thick line. So as we see here, we have to go this way. So first of all complete this half of the ellipse from G to C by thick line. Then we see here, if I join this, so C is falling on the boundary, similarly G is falling on the boundary. So join OG and OC also by thick line. And now for remaining points, we have to decide the direction of observer. As we have to look at this object, we are completing this top view. So this is the direction of observer. So we are looking from top. So as we look from top, we see here the base goes away. In case of cone, we have to just decide whether apex is nearer to the observer or base is nearer to the observer. So in this case, apex is nearer to the observer. That's why all the remaining points of the base must be connected by dotted lines. So here remaining points of the base are to be joined by dotted line, because base of the cone will not be visible. So this completes the required top view, along with, if you mark axis OP, so this is the required front view and top view of the object.